Hello, my name is Marcel and I'm from Group C4. Okay, the title of our PBL is Investigation of Voltage Set and their Mitigation Measures. Okay, in this PBL, there are three of my group members, which is the first one, Muhammad Syahid Izzat bin Zulkarnain, and myself, Marcel and the third person is Muhammad Azizul Arif bin Muhammad Azizan. Okay, let's move to the next slide. Okay, there are some objectives of this problem-based learning, or also known as PBL. For the first objective is ability to conduct a research on a particular problem with minimum intervention of the supervisor or the instructor. Okay, the second objective is ability to exercise problem-solving skills and communications or interaction skills. Okay, the third objective of this problem-based learning is able to analyze and propose solution to the problem and present the findings of the research conducted. Okay, that's all for the objective of this problem-based learning. Okay, let's move to the next slide. Okay, as we can see from this slide is for problem statement. For the first point, the problem statement of this coursework is to investigate the voltage sag and find the method of mitigation. Alright, the potential effect of voltage sag could be efficiency reduction, system shutdown, reduce the life expectancy of electrical equipment, especially in electrical motors or electronic components. Okay, based on this coursework, dynamic voltage restorer, or also known as DVR, were used to monitor and mitigate the voltage sag. Okay, this DVR was applied due to its ability to maintain the voltage applied to the load during sagging and swelling by applying a voltage of compensated amplitude and phase angle into the power line. Okay, that's the problem statement of this PBL.
Assalamualaikum. My name is Muhammad Azul Arif bin Muhammad Azizan. I'm from Group C4. Okay, hello, hi. So I'm gonna introduce what is voltage sag. Okay, voltage sag is usually known as a short duration reduction in RMS voltage, where it can caused by a short circuit, overload, or starting of electric motors. Yeah, it happen. Then the voltage sag cause failure in the transmission system, the distribution system, because of the rise in loads such as faults from tree falling or lightning or short circuit or anything that caused by abrupt rise of source impedance. And then a voltage sag occurs when the RMS voltage decrease between 10% and 90% of the nominal voltage for 1/2 a cycle to 1 minute. Can happen around that time. A longer duration of voltage will be a sustained sag. It will be called, it seems. And then we proceed with the effect of voltage sag. Okay. You can see that the voltage sag can affect the motors where it's reducing the speed, where after that the load torque or the load force will be higher than the motor torque. Hence the motor will bring down the motor speed and shut it down completely, which can kill some components in the motor, which is not good. And then we continue with the control system, where most of the control system is usually used in industry where they have many power electronic, so they can control a lot of things simpler, where mostly is highly sensitive to voltage sags, which can trip off the continuation of the process or anything that producing at that moment, which can cause a lot of trouble to the company and the industry itself. And then we continue to the financial losses. Something like oil and gases industry where usually they are very sensitive to electrical transmission, where if it happen, voltage sags happen, it can highly affect it, where the production process is decreased, or you can say is halted for a while, where you can see that in a day they can produce this much, and then suddenly they have to produce this much because of voltage sag, and it can result in a high financial losses, which very not good for oil and gases, where they are very sensitive about their financial.
Alright, in this slide we can see uh, there are some of mitigation methods, and for the first one is static bar compensator SVC, which is a shunt connected power electronic based device which work by injecting reactive current to the load. Okay. The second one is uninterrupted power supply, or also known as UPS. Okay, this UPS is mitigate voltage sags by supplying the load using energy store. Okay. For the third method is dynamic voltage restorer (DVR), and the fourth one is active series compensator, and the last one uh, ferroresonant transformer. So these are the mitigation method of voltage sag.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syahir Izzat Bizul Qarnain, and now I will present on the results and discussion. Okay, for the results, this is the circuit construction of line fault model without dynamic voltage restorer DVR. So from the circuit, it consists of 3-phase source, 3-phase transformer, 3-phase breaker, 3-phase VI measurement, 3-phase parallel RLC load, and 3-phase fault. And from this circuit also, we have injected the fault at phase A and phase B in order to find the set voltage from the circuit. Okay, next we go through to the waveform when we inject the fault at phase A and phase B. And this is the waveform of VABC of fault injection, and this is the waveform for the RMS voltage of fault injection. Next, this is the circuit construction of line fault model when we insert the DVR model in this circuit. So from the circuit, it consists of 3-phase supply, 3-phase transformer, 3-phase breaker, 3-phase parallel RLC load, DLG fault, and also the DVR. This is the main part of DVR. In the DVR, it consists of some subsystem of circuit in order to construct the DVR, and this is the circuit connection of DVR with subsystem of controller 1, and this is the circuit construction of controller 1 in DVR. Both of them is the subsystem of DVR. Next, we go through to the waveform after we injected the mitigation method into the circuit, which is DVR. Okay, from these two waveform, this is the waveform before we injected the DVR, and this another two waveform is the waveform after we inject the DVR into the circuit. So from the waveform here, we can see that the DVR will identify the set voltage that occurred in the circuit and try to repair it to become a normal voltage. From this experiment, we have injected the fault at phase A and phase B, where for the from the waveform, it is on waveform green and red, and after the DVR is injected, it will find out the set waveform and repair it to become a sinusoidal waveform, which is where we can see at the video here. So this is how the DVR operate in this circuit. Okay, next we go through to the simulation of the circuit. Okay, this is the circuit of line fault model without DVR. From the circuit, we have injected the fault at phase A and phase B. Okay, next we also use the simulation stop time of 0.1, and in order to simulate the waveform from the circuit, first we have to run first the circuit, and then we select on the simulation data inspector, and to find the waveform of VABC, we select on the 0.4K VBus, and this is the waveform of VABC when we injected the fault at phase A and phase B, and also before we inject any DVR method into the circuit. And then to find the waveform of VRMS, click here, and this is the waveform of VRMS. Another ways to simulate the waveform is we can just press on the scope here, is to find the value of VABC, and press the scope to find the waveform of VRMS. Okay, next I will show you on the simulation of line fault model circuit when we insert the DVR into the circuit. So this is the circuit of DVR insert. So to simulate the waveform from the circuit, we just have to run first the circuit, we wait until the time is count into 0.1 as we set here. Okay, next to simulate the waveform, we just press on the scope here, and this is the waveform when we injected the DVR into the circuit. Okay, next we go through to the discussion from this experiment. From this experiment, the mitigation method that we use is VDR, which is dynamic voltage restorer. The reason why we use the VDR method is it is the basic principle of the dynamic voltage restorer is to inject a voltage of required magnitude and frequency. It is very important because it can restore the load side voltage to desired amplitude and waveform even when the source voltage is unbalanced or distorted. For the second reason is the DVR can generate or absorb independently controllable real and reactive power at the load side. In other words, DVR is made of solid state DC to AC switching power converter that inject a set of three-phase AC output voltage in series and synchronism with the distribution and transmission line voltage. And for the third reason is the dynamic voltage restorer is also used to mitigate the damage effect of voltage swell, voltage imbalance, and other waveform distortion. So from the VDR also, it is used in the industry such as to protect steel industry load from power quality problems.
Okay, for the final part of the presentation, the conclusion is all the objective for this research of this voltage seg are achieved successfully, which the student have the ability to conduct a research with minimum intervention from the supervisor and then the student ability to analyze and propose solution by using MATLAB Simulink, and also at the same time the student learn more about voltage sag, the deep and the swell of the voltage sag, no, and the swell in the power system. So that's all. Thank you very much.